So this is why I'm doing example 2, because this one's a little different, okay? You are now adding the k part to this, and what is going to happen is, this part is no different, but then you're adding on the k at the end, and what that means is, guys, if it's in this form, if your graph is in this form, or your squared function is in this form, you're going to have what we call a vertical translation, which means that the curve is going to be moved up or down the number of k units. If k is -3, it's been moved down 3 units. If k is +4, it's going to be up 4 units. Okay? All right, here's one I want you to do with me. We're going to graph and compare again. Graph and compare. Y equals the square root of x minus 5 outside. All right, so now we have a different looking squared function. But do we still make a table first? We sure do. I'll make a table first. Okay, nothing new there. And really, again, it's nothing really hard. It's just going ahead and making sure you understand what your domain range will be. Okay? Class, what do you notice is the only thing under the radical? What's the only thing under the radical? Just x, right, Joe? Yes, it's just x. So what does that mean x has to be? Our independent variable has to be. What is our first number that we can use for our domain? 0. 0 is the first number we can use. It's the first non-negative number, so let's put 0 in for x. What's the next numbers we can go ahead and use? What are they now? We're getting used to these now. 1, 4, 9, and 16. Okay? Now let's put them in. Watch how I do this now. Okay? Here we go. Everybody got that written down, so they're ready to go? All right, what is the square root of 0? 0 minus 5. -5. Notice when you put this in your calculator, though, this is what you need to pay attention to. Do not do this. If you do y equals the square root of x minus 5 all under the radical, that's incorrect. Are these two totally different radicals?
Yes.
Yes. The -5 is not under the radical. So what I need you to do when you put this in your calculator is take the square root of the number x, push equals, and then subtract 5. So you don't get it incorrect. Okay? All right, what is the square root of 1? 1. Now 1 minus 5. -4. Good. The square root of 4. 2 minus 5. -3. Okay? Now take the square root of 9. 3. 3 minus 5. -2. Okay? Now take the square root of 16. 4. 4 minus 5. Negative what? 1. Okay. Now let's do our domain and our what, guys? Range. What's our domain going to be? X is what? Greater than or equal to what number? 0. Now, so far we've had just a domain of x greater than or equal to 0. Not all the time is that going to be the case, so I want to be prepare you for that. All right, what's our range going to be? Y is what? What number do we start with? -5. Put that there, but what inequality do I use? Greater than or equal to or less than or equal to? Greater than or equal to. Good. All right, there's our domain and range. Now I need to look to graph it and then compare. All right. So I'm going to go ahead and erase my other graphs from before, but I'm going to keep my y equals the square root of x up here. Because that's what we're always comparing our graphs to. Okay? Now let's go ahead and graph mine in red. 0, -5. So over 0, down 5. 1, 2, 3, 4, 5. There's that point. Over 1, down 4. Over 4, down 3. As you see what's happening, you notice that every one of my points has moved down how many units? Do I have to really go ahead and do the rest of these, or can I just go ahead and move down how many points? How many points am I moving each, or units am I moving each one of these points down by? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And do I have a curve that I can draw? A smooth curve? Oops. Okay, tell me right now, do they look like the same shape? There's nothing different with the shape, is there? So is there any vertical stretch or vertical shrink? But what's the only difference? This graph has been done. What? What is this graph? Y equals the square root of x under the radical minus 5 outside, different from y equals the square root of x. It's only been moved what?
5 down.
5 units down. There you go. That's all that's different about those two graphs. Because look, don't they have the same a? Don't they have 1 in front of the square root of x? Does that mean a is the same? So it's a is the same. If a is the same, class, there's going to be no difference in the shape of the curve. There's not going to be any vertical stretch or vertical shrink. So therefore, the only thing that's been done is this thing's been moved down 5 units. That's the only thing that's different about the graph, the right curve to the left. So the only thing we're going to say as a comparison is, so under comparison, you're going to say y equals the square root of x minus 5 outside the radical is a vertical translation of 5 units down from y equals the square root of x. There you go. We're done with that one. Okay? We got one more and we're done. And this is, like I said, this will be the hardest. 11.1 and 11.2 will be the two hardest sections. So it's nice to know that we're already almost done with 11.1.